In this video, we'll take a look at section 3.1, which is on systems of equations in two variables. Our first objective is we're going to be determining if an ordered pair is a solution to a system of two equations. So first, let's take a look at the definition of a solution. A solution of a system of two equations in two variables is an ordered pair that makes both equations a true statement. Okay. So let's take a look at the first example. Is 1, 2, so is the ordered pair 1, 2 a solution to the system? Now just remember, whenever we have an ordered pair, the first number in the ordered pair is our x, and then the second number is our y. So we want to check to see if it's a solution to the system. In order for this ordered pair to be a solution to the system, it has to make both of those equations a true statement. So let's go ahead and start plugging it in. So for our first equation, we have y minus 2x is equal to 1. So let's go ahead and start plugging in our x and y values. So we have y, which is 2, minus 2 times, and our x, which is 1. We want to see if this is equal to 1. We want to see if this is true. Well, let's go ahead and simplify this. So we have 2 minus, now 2 times 1 gives us 2. We want to see if this is equal to 1. So the 2 minus 2 gives us 0, and we have equal to 1, which is of course not true. Now, since right away it doesn't make the first equation true, we don't have to check the second equation. It doesn't matter, because it has to be a solution for both equations. So since it's not a solution to the first, 1, 2 is not a solution to the system. Whenever you're trying to check to see if anything is a solution, remember you're going to be plugging it in. So plug in your x, plug in your y, and see if it's a true statement. Let's try this next problem out. So is 4, -2 a solution to the system? So let's go ahead and check the first equation. So we have 2 times, and our x value here is 4. And we have plus, and then our y is -2. We want to see if this is equal to 6. We want to see if this is true. So 2 times 4 gives us 8, and we have -2. So 8 minus 2 does give us 6, so it makes the first equation true, but that doesn't mean it's a solution to the whole system yet. We still have to check the second equation. So let's go ahead and plug it into the equation. 3x plus 4y equals 4. So we have 3 times, and now our x value, which is 4, plus, and we have 4 times our y value, which is -2. We want to check to see if this is equal to 4. Okay, so the 3 times 4 gives us 12. 4 times -2 gives us -8. So 12 minus 8, that does give us 4. So it works for the second equation as well. So that means that 4, -2 is a solution to the system. Now, for both of these examples, we were given an ordered pair and we have to figure out what the solution is. But most cases, we're not going to be given an ordered pair. We're going to be given 2 equations, and we have to figure out what the solution is for that system. Okay, so that leads us to our next objective. We're going to be solving systems of 2 equations by the graphing method. So we're going to learn a few different types of methods. We have the graphing method, we have the substitution method, and we have the elimination method. For this particular section, we're going to be taking a look at the graphing method. Now, the graphing method, what you're going to do is graph each equation on the same coordinate plane. Now, the point of intersection, this is the solution. So the point where the 2 lines intersect is going to be your solution. Now, with this graphing method, you have 3 different cases. The first case is if you end up with one solution. So that's if you draw the graphs for each line. and then that point where they intersect, this will give you one solution. Okay, that point where they intersect each other, that is your solution to the system. So this is case 1. Case 2 is if you have no solution. So remember, the solution to these systems is the point where they intersect each other. Well, you might end up graphing each one of these lines that never intersect each other. You might end up with 2 parallel lines. So if you end up with parallel lines, what that indicates is you have no solution because they never intersect. So if you end up with parallel lines, you have no solution for that system. There isn't a combination, there isn't an ordered pair that makes that system true. Now case 3 is infinitely many solutions. Now infinitely many solutions is if you draw both of the graphs and it's exactly the same line. So I drew these 2 lines, they overlap each other. So with infinitely many solutions, these 2 lines, they intersect at every single point, which indicates you have an infinite amount of solutions. So when you're graphing these 2 equations, if you end up with the same line, that indicates that you have infinitely many solutions. There's more than one solution for that system of equations. Now let's take a look at some examples. So solve the system of equations by using the graphing method. So we're given the equation negative 2x plus y equals 1 and 3x plus y equals 1. Okay. So we want to go ahead and graph each one of these equations and see where they intersect, or if they never intersect, or if it's the same line. So let's start off with our first equation, negative 2x plus y equals 1. So in order to graph it, let's go ahead and get into slope-intercept form. So we could use the slope and the y-intercept to graph. So we have y is equal to, so I subtracted 2x from both, I added 2x to both sides. So I get y is equal to 2x plus 1. This tells me my slope is 2. And my y-intercept is 0, 1. Now I'm going to color coordinate these. So I'm going to refer to that one as the black graph. So I have the point 0, 1, and now I use my slope to get one more point. Okay, so remember, our slope is really 2 over 1, so I'm going to rise 2 and then go to the right 1. I get this point. Okay. Now instead of going up 2 into the right 1, I want to also go down 2 into the left 1, just to get another point, so it's going to help me draw a nice straight line. Because when you're using this method to solve these systems, you want to try to draw as straight of lines as possible. Okay, so we get this graph right over here. Okay. Now let's take a look at this next equation. So I have 3x plus y. So I want to graph this as well. So I have 3x plus y is equal to 1. So let's go ahead and get the y by itself, get into slope-intercept form. So I'm going to subtract 3x from both sides. I get y is equal to, I have negative 3x plus 1. So my slope in this case is negative 3. Let's go ahead and put it as negative 3 over 1. So we have a rise over run. And my y-intercept is 0, 1. So let's start off with my y-intercept, which is this point. And I'm going down 3 into the right 1, which gives me this point right over here. And now let's connect these with the straight line. Okay. So we have our 2 graphs. Now the point where they intersect, which is right over here, this is the solution to our system. So just read off what that point is, which is 0, 1. Okay. So now we have the solution. We have the solution to the system. But whenever you're using the graphing method, there's always like room for error, especially if you don't draw a straight line. If you don't have a ruler to draw a straight line, always plug it in and see if it gives you a true statement or not. So if I plugged in 0, 1 into the first equation, I get negative 2 times 0, which is 0, and then plus 1 gives me that 1. So it makes the first equation true. Now the second equation, 3 times 0 gives me 0, plus 1. So the 3 times 0 gives me 0, and then plus 1 gives me 1 as well. So it works for the second equation also. So it means that 0, 1 is the solution. Let's go ahead and take a look at another problem. So solve the system of equations by using the graphing method. So we have 3x plus y is equal to 5. Okay, let me color coordinate these. So I have 3x plus y is equal to 5. Let's get this into slope-intercept form. So subtract 3x from both sides. I get y is equal to negative 3x plus 5. So my slope is negative 3, and my y-intercept is 0, 5. So let's go ahead and graph it. So 0, 5 is that point right over there, and then my slope is telling me to go down 3 and then to the right 1. Let's go down 3 again and to the right 1, so I have more lines, more dots, so I can connect them a little bit easier. I get this point. And now let's try to connect them with the straight line. So I get this line right over here. Let's take a look at our second equation. We have x minus 2y is equal to 4. So let's get this into slope-intercept form. Let's go ahead and subtract x from both sides. Okay, we get negative 2y is equal to negative x plus 4. Okay, now let's go ahead and divide by negative 2. Okay, this gives me y is equal to, so the negative x divided by negative 2, this gives me positive 1 over 2x. 4 divided by negative 2 gives me negative 2. So my slope in this problem is 1/2, and my y-intercept is 0, negative 2. So let's go ahead and start with our y-intercept, which is right over here. And now let's use the slope to find one more point, or a couple more points. So my slope is telling me to go up 1 and then to the right 2. Okay, perfect, I get this point. Let's go up 1 to the right 2 again, get this point. Connect them with each other and we get this line. Now the point of intersection is right over here, which is our solution to this problem. So let's read off that ordered pair. It's 2, negative 1. This is our solution. Remember, always double check to make sure that is the actual solution. Let's take a look at this next problem. So our first equation, we have y plus 2x is equal to 3. Getting it into slope-intercept form, subtract 2x from both sides. We get y is equal to negative 2x plus 3. So my slope in this case is negative 2, and my y-intercept is 0, 3. So that's 0, 3, and then I have my slope, which is telling me to go down 2 and then to the right 1. At this point, we go down 2 and to the right 1 again to get another one. And now we could go ahead and connect these with each other. Okay, and now we have our graph. Let's take a look at the second equation. We have y is equal to negative 2x minus 4. For this equation, it's already in slope-intercept form. So I could read off my slope is negative 2, and my y-intercept is 0, negative 4. So 0, negative 4 is right over here. And my slope is telling me to go down 2 and to the right 1. Let's go down 2 to the right 1 again. I get this point. And now let's connect these with a straight line. Now notice the lines that we graphed, they never intersect each other. These are parallel lines. So these are parallel lines, which means we have no solution because they never intersect. Okay. Now, before even graphing each one of these equations, I could have known that these were parallel lines. So if you take a look at the two equations that we had, the slope for both of these equations is -2. And since the equations are not exactly the same, you have a different y-intercept over here. That means it's not the same line. So since they have the same slope and they're not exactly the same line, that means that these were parallel. Now let's go ahead and take a look at one more problem. So we have 2x minus 5y is equal to 10. So let's get this into slope-intercept form. Subtract 2x from both sides. We get -5y is equal to -2x plus 10. And now we could go ahead and divide both sides by -5. We get y is equal to, this gives us 2/5 x minus 2. So my slope is 2/5 and my y-intercept is 0, -2. Okay, so let's graph it. So 0, -2 is this point. And then my slope is telling me to go up 2 to the right 5, which would put me over here. Now I can connect them with each other. Let's take a look at the other equation. So we have -6x plus 15y is equal to -30. So let's get this into slope-intercept form. So add 6x to both sides. This gives us 15y is equal to 6x minus 30. And now divide both sides by 15. So I get y is equal to, now 6x divided by 15, so 6 over 15, I could simplify that. 3 goes into both of those. I get 2 over 5x. Now -30 divided by 15 gives me -2. So now my slope here is 2/5. My y-intercept is 0, -2. And now if we graph it, okay, 0, -2 is this point. I go up 2 into the right 5, gives me this point. And I could connect them with each other. And that gives me the same exact line that I had earlier. Okay. If we take a look at the equations, when we got into slope-intercept form, notice they're exactly the same equation, which means it's exactly the same line. So that's indicating they intersect at every single point on that graph, which means we have, so this is the same line, which means we have infinitely many solutions. So this whole section that we just went over, it was really graphing. It's really just like a review on graphing. And then you have to find out where the graphs intersect each other, if they ever intersect at all. Okay. So that was it for 3.1. As always, let me know if you have any questions.